I hope you're all safe. I'm sequestered here in Southern California. My presentation is going to be oriented around the business issues and how we are getting this technology out into the marketplace. I'm going to share my screen with you now. Of course, I'm going to get to the very beginning. I wanted to say a couple of things before we get started. We work directly with Georgia Institute of Technology, and we are the sole licensee of the technologies that have been developed there. And not only do we have licenses for that, but we're also working with Georgia Tech on creating new intellectual assets that we will be patenting in the future. So our portfolio of patents is increasing. And so one of the things I wanted to do was to share with you a video that we created a little while ago that gives you an idea of some of the areas that this technology can be used for. You will see Anna again, you will see some of her colleagues, and this is going to give you a clue as to some of the projects we're working on. And then, because we can't name names, because we like to protect the intellectual assets of our customers. So for those of you who have exhausted your Netflix.
For years, we've fantasized about color-changing technology. From cars to screens to clothing and beyond, we've only dreamt of the possibilities. Until now, color on demand is now a reality.
My name is John Reynolds. I'm a professor of chemistry and biochemistry.
The Reynolds Group at Georgia Tech are recognized as some of the world's leading experts in electrochromic polymer materials science.
The ECP technology stands for electrochromic polymers that change color under an electrochemical stimulus. And in essence, we could capture any color of the rainbow.
So an electrochromic device actually consists of 5 different layers. We're going to have current passing through the cells, through all the different layers. And what's going to happen is that the molecules are going to change their shape or their conformation. And that's going to change how they interact with light. All right, so we're going to start off by coating our colorless polymers.
Creating a structure that includes a conductive surface to transport electricity, we apply the polymer components, the clear polymer, an electrolyte to conduct the electricity, and the color polymer.
So I'm going to show you how we switch an electrochromic device. And to do that, I have a laptop right here that's going to control something that we call a potentiostat. And what that is basically a battery. And that's going to hook 2 wires that I'm then going to connect to the electrochromic device. And once I hook it up to do that, I'm going to apply 1 volt. The device will switch between its color and its colorless state, where it's causing it to lose electrons and causing it to gain electrons as we apply 1 volt.
Think of the color like a ribbon. Looking at the ribbon full on, you see the color. But as we apply an electrical current, the molecules of the ribbon twist, and the color appears to get lighter as it moves into the invisible spectrum to become transparent. The color, or clear state, will remain until we apply the current again. This is unique in the industry, and only chromatics can do it. With over a dozen global brands currently developing with chromatics, the future is about to get a whole lot brighter. Chromatics, welcome to the color revolution.
She combs her hair, she's like a rainbow.
So that's the introduction to the brand that we're calling this, Chromatics. As we move forward, our business model is that we are working with global leaders, I would say, in the retail and manufacturing spaces to basically change the way they think about using color in their products. We have exclusive licensing mechanisms. Generally speaking, that the people we work with will have an exclusive field of use license. Our revenue model is that we receive our revenues through license fees. At first, we had a model that was typical of many licensing fees that required our customers to audit and provide feedback on the products that they sold, and it was predicated on what those products were. Yanni at Ynvisible and I worked on a model that simplified the process by building our licenses into the supply chain and into the polymer itself. It simplifies the process, it makes it easier for customers to do business with us, and it certainly makes it easy for us to recognize revenue. We also do technology consulting because, as Carlos said, some people are pretty sophisticated about understanding this technology, others are just getting their feet wet. And we work with Ynvisible to develop prototypes and to develop technologies with our customers and help them get to the stage of realizing their vision into practical applications. And then we also engage in fundamental research. We have customers that we're working with who are fairly sophisticated and know that they want to create maybe some specialized molecules or specialized functions. I did see a question about the longevity of the materials and what it works on. I think Carlos and Anna covered that, but we're seeing tens of thousands of switches using our technology. And I do know that at some stage, Anna had a slide in her drawer that she pulled out after 2 years, and it worked instantaneously. And so we are looking at good, stable performance of our products. Now, when you saw the video, there were some fun ideas in there. We are working with some major global suppliers, and these are some of the areas that we're working on. Automotive interior and exterior components. You can imagine things, for instance, like color changing decals on cars, or even working at some stage on building color changing wraps so that the whole car can change. On eyewear and optics and frames, we are working diligently on a variety of areas in optics with some very large partners. General consumer products, I think Carlos covered that in his fun slide about all the different products that were in the household. Architectural interiors is something that we're particularly interested in because the architectural window space is pretty well covered by some very advanced companies. But we are working with a group at the moment to talk about the interiors of buildings, the color changing walls, for instance, and there's a lot more wall space in a building than there is exterior window space. In packaging security, you also saw that Ynvisible have been working on packaging products. Our colors can represent certain features for security. I think of chain of custody, for instance, is one of those applications where we can identify whether a product has been thrown out of the chain of custody or bypassed it, or whether a package has been dropped or not, so that you can tell before you even open it whether it's maybe damaged. Sportswear has become rather exciting because, as I will go through in a little bit in the next slides, we've been actually working with stretchable electronics. And we did a test very early for one of the companies we were going to partner with, and we've been successful in getting our polymers to change color on stretchable electronics. Mobile phones and devices, those you can imagine as what they are. In glass, we're looking at automotive glass and marine glass. You know, one of the features of our product is that once you change the color of our window, for instance, you won't need to use electricity to maintain the state. And that was particularly important in the marine applications we're looking at. In aviation, we're looking at aesthetics and safety features. In cosmetic products, we've had discussions with some of the cosmetic companies about color changing fingernails, for instance, which you may have seen in the movies in the past. And we're looking at color changing furniture, flexible displays, where instead of having active displays that you see ubiquitously everywhere, you will see reflective displays, more like color changing paper. And recently, we've made some discoveries that because of the absorption qualities of our polymers, we have some military applications that allow us to absorb a specific laser light, which has some strong implications in terms of our ability to enter a new market that we hadn't previously been looking at. And optical filtering is another area which is aligned to that military application, but this is where we can filter out specific light frequencies and build visual acuity, especially in optics. Now, we're going through a troubling time. A lot of the companies that I've been speaking to, some of which are trying to reserve their treasury so that they can withstand the downturn. Many of our customers, retail locations have shut down, their manufacturing plants have shut down. And some of these people are backing away to see how we recover from this economic calamity that we're going through. However, we have many others who are using this opportunity to ask themselves, how did they regain market share once this market turns around? How did they create products that people are going to want to buy that are not the same old Me Too products that were out there in the past? How do we actively encourage people to want to spend their money with us rather than someone else? Are our brands going to be important as they used to be in the past? And so we're working with a few of these innovators who are using this time to innovate and project into the future the ability to gain revenues that they might not have seen, and to certainly accelerate themselves into the marketplace. So they're going to come up with new categories of products. And we're investing with them, and they invest with us into the things they want. We're expanding our color palette. The little diagram that you see here, it gives you an idea of the color palette that is in existence at the moment, although we have broader characteristics in yellow. But we're going to be expanding to the full outer edges of the color gamut. We're building new molecules for specific types of applications. We're looking at new wavelength concepts because we want to be able to tune the wavelengths for specific applications. We're looking at new conductivity methods. As you may have seen in the video, we had a clear polymer that we used, and that was basically used to absorb electrons. And some of Anna's colleagues have been working on the idea of highly dense ITO layers on the conductive materials that allow those electrons to be stored directly onto the surface, thus changing the architecture slightly and improving it by reducing at least one component in the development of the color changing material. We are looking at new materials, stretchable electronics, and new films. We are looking at thinner and thinner films because we want to see moldable films that can go onto surfaces and enter into the standard manufacturing processes that are well known. And we're looking at new barrier coatings because in automotive applications or other applications where the colors are going to be exposed to tough atmospheric conditions, or for instance in cars, rocks popping up and hitting the material, we want to have coatings that have good ballistic characteristics, and we're investing in looking at those and working with customers that have and partners that have made some advances that look very promising for the future. So we continue to invest, and our customers continue to invest with us. And that's important for another reason. When we're working with our customers, confidentiality is a key factor. Many of our customers have ideas that they believe will give them a significant competitive advantage in the future. And for them to be able to do that work and conduct the research during the testing periods, we need to keep the intellectual property confidential. And so one of the key factors that we developed was the ability to build an academic firewall. As many of you may know, if you partner with an academic research organization and you sponsor research, much of that research will be published, and that may not be good for you from a competitive advantage point of view. But with us, we've developed a firewall capability. You can work with our academic resources, have access to the know-how, and share your know-how with our scientists, and fully protect your intellectual assets. Well, that leads to the access to our academic science and research. And you can also sponsor direct research into specific kind of chemistry that you would like to have worked on. If you know of a particular area you want to work in, we'll work with you, and you can engage in fundamental sponsored research with our academic resources. But also know that that development will be kept confidential. Summarizing, it's a disruptive technology. We can create unfair advantage. We have a vibrant color palette. We have very fast switching, optical memory, which is important, world-leading academic corporate support. Our firewall and exclusive field of use licenses are still available. Thank you.